Good day, ladies and gents. This is Sarel van Grinnen, aka Mr. VG, and I am excited to be on this journey with you, journeying through having fun while doing mathematics and conquering these big evil dragons that we see on a daily basis. Now, I encourage you, if you haven't watched the videos about the grade 12 or the grade 11 theory, hit the pause button. Rather go back and first check those videos out, because we're going to need both of those videos to help us for today's lesson. For today's lesson, we are going to look at two exams. One from a GDE paper, one from an IEB paper. But please do not think that one should be asked or one can't be asked or won't be asked. They could be asked in any exam. So I encourage you, buckle up, have fun on this journey we are on. So let me quickly raise my topic and let's start with question 1. Now question 1 states the following. In the diagram, triangle AGH is drawn. F and C are points on AG and AH respectively, such that AF is 20 units, FG is 15 units, CH is 21 units. D is a point on FC such that ABCD is a rectangle with AB also parallel to GH. The diagonals of ABCD intersect at M, a point on AH. Now that is usually how my matric students, how they read a sketch like this. But what I would like you to do, I'm encouraging you to not do this. To not just read everything at once, then look at the question and go, how can I prove that? What I actually want you to do is step by step, as you read something, make sure that you look at all the different theorems that apply to it. So let's restart our reading through and just read through it step by step. So in the diagram, triangle AGH is drawn. So I've got a big triangle AGH. F and C are points on AG and AH respectively. Now that doesn't mean much for me, such that AF is 20, FG is 15 units, and CH is 21. That's awesome. They indicated it on the sketch, so I'm not going to write it on again. D is a point on FC such that ABCD is a rectangle. Boom. Let's stop the bus there. Let's just have a look. What does it mean? Now I need to look at all the theorems that have to do with rectangles. If I look at all the theorems about rectangles, first of all, there's a lot of stuff, so let me back up. First of all, with a rectangle, the diagonals are equal to each other. So AC is equal to BD. That's an important little note that we are going to use. Secondly, the diagonals also bisect each other. So AM is equal to MC and MD is equal to BM. And they're all equal because the diagonals are actually equal to each other. A nice extra thing that I just thought about now is there's also some 90 degrees in there. Might not be useful, but you actually don't know, because we actually don't know exactly where we're going with this. We're just going through the information. There's a few. Let's do all the 90s so we make sure we don't miss anything specifically. If I now look at the rest of this sum, okay? If I look at the rest of the sum, let's quickly look. We also have parallel lines. Not just those ones, but also that AD is parallel to BC. I sometimes draw too much information on a sketch, but I'd rather do too much than too little, because if I do too little, I might miss something. Let's quickly look at the first question, 8.2.1. I want to prove that FC, okay, is parallel to GH. So let's look at what do I know. I know that AB is parallel to GH because that was actually given for us. Now, why do I start with AB and GH? Because I actually look at GH. I'm trying to see what do I know about GH. Next up, I now go and look, I've got AB, I've got GH. What else do I know? Well, what else do I know about AB? Well, AB is actually parallel to FC because it's the opposite sides of a rectangle. Okay? And now I've proven what I wanted to prove. I have now proven that FC is parallel to GH. That's my logical statement. Please, at this moment of time, do not jump too quickly into 8.2.2. Okay? I know that I'm writing 8.2.2 already, but before you actually jump into it, let's have a look. What does it mean now that FC is parallel to GH? It means that AF over FG is equal to AC over CH. Because why? Because I've got that parallel side. So therefore, theorem 1 comes into play all of a sudden. Let's now actually look at what they want us to prove. They're asking me to prove DM. So something to do with DM. Now, what I like to do, as a matter of fact, is I would like to constantly look at DM and think, but how does that relate to all the other stuff? Now, I know that DM relates perfectly to BM, as well as AM, as well as MC, because they are all those little half of the diagonals that I can work with. If I look at AC, which is the one that I can use, I now have a kind of a place, because if I can find AC, then I can find AM or MC. As well as if I can find AC, I can maybe find BD. And if I can find BD, then I can find DM. So let's start by, narrowing this down. I need to get AC. So in other words, I go to my ratio that AF over FG is equal to AC over CH. Now, why is that? Let's just not forget our reason. That line is parallel to one side of the triangle. I don't want to lose that mark, so let me write it in. So 20 over 15 is AC over 21. Now I want to get rid of that divide by 21, so I'm going to times both sides by 21, which means AC is equal to 28 units. So what I like to do is write it in on my sketch. Now I know that AC is equal to BD. Again, look at the path I want to go. If I can find BD, then I can find DM. Now AC is the same as BD because they are diagonals of a rectangle. And therefore BD is also 28. And therefore MD is 14 centimeters. And our reason is diagonals of a rectangle. Now, my apologies for using centimeters here. That's not right. That is actually units. And there, ladies and gents, I have just proven, we've just gotten a length of dm, and hence my question is done. I know I'm taking a lot of time on a 6 mark sum, but remember, I'm explaining it while I'm doing it. Now, this for me personally was not a really tough question. Not saying it was easy, but it wasn't that tough. So what I'm going to do in this next one is I'm going to tackle a bit more of a doozy, a bit more of a tough one. So let's have a look at this next question. My next question was found in an IEB paper. Now, before I actually look at the question, I'm just going to look at the info and I'm going to run through this. I encourage you to hit the pause button, try this question yourself before you look at the way, or just interpret this one. Just, hit the pause button. You can find this specific example. I will put a link in the description so you can maybe print it out, or you can write on the sketch. Look at what am I doing and how am I doing this? But first try it yourself. Now, if I do the sum, I'm going to start by the information. So let me start. First of all, AB is a diameter of the larger circle. So in other words, because AB is the diameter, little c, or angle C, is 90 degrees because of angles in a semicircle. Next up, because AL is the diameter of the smaller circle, I've got 90 degrees there. Now that for me I kind of like, because I'm already seeing some connection between those two angles. I hope that you are seeing it as well. Because if you look at question A, we're needing parallel lines, but let me not jump the gun too quickly. Let's go through the rest of the info first. Then they tell me S and L are centers of the circle. Now that's important because I need to start at the definition of the center of a circle, which means I've got equal sides. If I've got equal sides, I've got equal angles because I have an isosceles triangle. Also, I've got another isosceles triangle SDL. Next up, I'm going to look at L being the center of the bigger circle. Oh wait, I jumped the gun. I forgot that in this little triangle, that angle there, angle S, that angle is twice the angle at the circumference. Also, that angle there is twice that angle there. Might not be useful, but might not be useless. You don't know yet. Okay? So let's quickly have a look at the rest that I want to have a look at. The rest I want to have a look at, first of all, is the bigger circle. That center. So LC is equal to LB. In other words, that angle there is equal to that angle there. If AL is equal to LC, then that squiggly angle is equal to the top squiggly angle. Because again, I've got isosceles triangles. Again, I do different colors because colors work for me. I encourage you to do the same at home. Even in the exam, I don't know whether they will allow you to use colors in the exam. Find out from your teachers. But let's have a look at what I'm going to do next. Next up, they tell me that M is a point on LB such that MN is parallel to LC. Oh, I love that. because I've actually got so many theorems about parallel lines. I can use the F, the U, the N, so corresponding co-interior alternate angles if I want to. Or I can go to theorem 1, which says that LM over MB is equal to CN over NB. There's so many theorems. I'm getting too excited about this. Let me calm down. Okay. Now, I'm not necessarily going to look at the F, the U, and the N, but it's worthwhile to remember that that little angle there, let me do 3 dots, is equal to that little angle there because of corresponding angles. Also, that angle relates to that angle. Let me do it up there. Again, corresponding. Now, I'm not saying I'm going to use it, but let's see where this thing takes me. If I look at the first question is asking me to prove DL parallel to CB. In other words, I can prove this by either using the F, the U, or the N. Now, the beautiful thing about the first thing that I did was I've got those two 90 degrees. So I've got that 90 degree there, and I've got that 90 degree there. And because they're both 90, I know that I've got corresponding angles that are equal. So I've proven it. But let me actually write it down. Now I know that angle ADL is 90 degrees because of angles in a semicircle. And I know that ACD is 90 degrees for the same reason. And therefore, ADL is equal to ACD, and therefore DL is parallel to CB because the corresponding angles are equal. Please make sure that your reasons are 100% correct. Okay? Woo! Let me get just a sip of coffee, and then I'm carrying on. Yes. Let's look at the second question that they are asking me now. The second question is, prove that SD is equal to LC. So now I've got to try and relate. How does SD relate to LC? So let's start by looking at LC. Now LC, I know it's equal to AL and LB because of the radii to the big circle. Now LB doesn't come close to SD, so I'm going to eliminate it, and I'm rather going to look at AL because that's the diameter of the smaller circle. So AL relates to 2 times the radius, which is actually SD. So now I've just got to write this down for the examiner. First of all, AL is equal to LC because it's radii of the big circle. Then AL is actually 2 times by SD because LC is the diameter. And therefore LC is 2 times by SD. Not very complicated at all. So let's quickly have a look now at the next question. Now I'm going to skip over to a new whiteboard here. Please hit the pause button, write down, make sure that you get this question right, make sure that you are well versed and you're happy with this before we go on. If you've got questions, please feel free to ask. Ask your teacher. I know they will gladly assist you. In the next question, so question C, what I just did was I just looked at what are the information that I'm carrying over from the previous one. Now, I just forgot to put in the big radii. But let's quickly have a look at the next question. The question is, determine the value of SL over AB. Whenever an examiner asks me a ratio like this, what I love to do is I like to bring in X's and Y's. So for instance, let's bring in an X for SL. Well, then I've got quite a few things that actually come in play here. If SL is X, then AS is also X because it's radii. AL is therefore 2X. And therefore LB is actually also 2X. Which means I actually have AB. But let's quickly write this down for the examiner. Let's say to them, let SL be X. Remember, if it's not given to you, then rather write it down for them. Then AL is 2X because it's a diameter. And therefore AB is 4X because that is now again the diameter of the big circle. I hope that you're seeing what I'm doing. I'm starting at one of the places, so I started SL and I just related constantly to how can I get towards AB. Which means SL over AB is X over 4X. And the X's divide away, leaving me with 1 over 4. Now, that exactly how, if you want to write reasons, you can go and explain this to them and say to them, it's because of radii. Or, I don't actually think it's necessary to write out many explanations because the examiner would actually know where you're going and where you come from in a question like this. The next question for me was a lovely little question. The next question asked, if AB is 30 units and BN over NC, oh, I love this because we're now starting to look at that bottom triangle with the parallel lines, theorem 1. Then determine the length of LM. So if I look at this, let's first write in on the sketch what we've got. So first of all, AB is 30 units. I'm going to relate this down to what I previously had because I need to go towards LB. So LB is then actually 15 units because it's a half of the big diameter. Now I go towards again BN and NC. Because they're working with ratios, I'm going to bring in now Y instead of X because I've already used X at the top, so I don't want to bring in X again. So I'm going to say that BN is 7Y and NC is 9Y. Now, looking at that little triangle, I've got LB, which is the longest side. So let's look at what is BC. Now, BC is 16Y. That's simply 7Y plus 9Y. Okay? Which means I'm going to relate now the BC and the LB to the NC and the LM. So I'm going to look at my parallel lines and write that LM over LB, so in other words, LM over LB, and that relates to NC over BC. And our reason is line parallel to one side of triangle. If I look at then substituting in, LB is 15 NC is 9y and BC is 16y. The y's divide away, fantastic, which means I'm going to get an actual value. And therefore I'm going to multiply by the 15 on both sides. And therefore LM is 135 over 16. And you can find a value for that. That's 100%. I'm not going to worry too much because I've got a length. And therefore I've answered the question. Woo! Maths gets me all excited. And I am happy to have done these two sums with you. My encouragement to you is go and practice this. Go and practice these kind of sums. Get some old exams. On the program, there's a lot of exercises for you to go through. Make sure you get the worksheet. Get the memo. Make sure you get it right. Remember, you can do much more than you think you can. This is Mr. VG. And I want to tell you, it's a privilege to do these videos for you. Remember to subscribe to the channel and to look out for the next video, which will be about Theorem 2 and exam questions. That's going to be a nice, beautiful set of questions. I can guarantee you that. Remember to subscribe and have a wonderful, wonderful rest of your day. Keep well. Cheers.